The word or, we use it every day, right? It seems so simple. But in the world of data, or can be, well, deceptively tricky. We're going to dive into a puzzle that trips up pretty much everyone, and we'll be using data from one of the most famous tragedies in history. Think about the Titanic. It wasn't just a shipwreck. It was this massive human catastrophe. Over 61% of the people on board, that's 809 souls, they never made it home. It's so important to remember that behind every single data point, there's a person. And that's really where our story begins. So what we're going to do is take on what's known as the Titanic Data Challenge. We've got the passenger list, and we've got one simple question. Sounds easy, right? But you'll see, getting to the right answer is a journey. It's going to take us through some of the most common traps that people fall into when they're working with data. Okay, so here's our mission. We have this big spreadsheet of Titanic passengers, and we need to figure out how many of them were either female or less than 10 years old. That's it. Female or a child under 10. Seems totally straightforward. But is it? Let's find out. All right, this is where it gets fun. It's kind of like a detective story. We're going to try to solve this thing a few different ways. But here's the twist. Every single attempt is going to give us the wrong answer. And each time, it'll be for a totally different and, honestly, a really interesting reason. Okay, attempt number 1. What's the first thing you'd probably do? I know what I'd do. You reach for the easiest tool you've got, the filter, right? You just click a couple of buttons and boom, you should have your answer. And look, the filter is an amazing tool. It's great for quickly sorting through your data. You can easily filter for just the female passengers. You can filter for an age less than 10. But the problem pops up when you try to do both of those things at the same time. And what do we get? 39, which is wrong. So what happened? Well, here's the critical thing to understand. When you stack filters like that, the spreadsheet is looking for people who meet both conditions. It's looking for passengers who are female and under 10. But remember our question? It was or. And that is a huge, fundamental difference. Okay, so the simple filter was a bust. What's the next logical step? Well, for a lot of people, it's time to build a formula. We know the filter was using AND logic, so let's try an if formula with an AND function built right in. Maybe that'll give us the control we need. So this is the formula we'd build. For every single row, we're telling a spreadsheet to ask, is this person female and is their age less than 10? If the answer is yes, mark it with a 1. If no, a 0. But, hang on a second. This is the exact same logic the filter used. Let's see what number this gives us. And the result is 117. Still wrong. But wait, why is it different from the filter result? What's going on? Well, we've just stumbled upon a really weird quirk in spreadsheets. See, the filter just ignores any blank cells. But a formula treats a blank cell as the number 0. And since 0 is less than 10, our formula is now counting people who have no age listed at all. So we've just uncovered a whole new problem. All right. Enough of this and business. Our question literally has the word or in it. So let's use the or formula. This has got to be it, right? We're just going to tell the spreadsheet exactly what we want. Find passengers who are female or under 10. I mean, look at that. It's perfect. It reads just like plain English, exactly like our question. If the person is female or their age is less than 10, count them. It feels like we're finally on the right path. This has to give us the right answer. And the result is 694. Whoa, okay, that is way off. What on earth just happened? Remember that little problem with blank cells we found a minute ago? Well, it just got 1,000 times worse. With the OR logic, every single person who has a blank for their age is now being counted because the formula sees that blank as 0, and 0 is less than 10. Our little problem is now a huge problem. So let's just pause here for a second, because this is a really big deal when you're working with data. The trouble with blanks can absolutely wreck your analysis. To you and me, an empty cell means I don't know. But to a formula, it means the number 0. And that silent, invisible translation from unknown to 0 is what's completely destroying our results. We have to be explicit and tell the spreadsheet exactly what to do with them. Okay, new plan. We've identified the villain. It's the blank cells. So let's build a smarter formula. Let's design one that tackles that problem head on. The idea is to tell it, hey, first, check if the age cell is blank. And if it is, just throw that person out. Don't even count them. So check out the logic here. It's a bit more complex. The very first thing the formula does is ask, Is the age cell blank? If it is, it just puts a 0 and moves on. It stops right there. Only if the cell is not blank does it continue on to our original OR check. This feels really solid, like we've finally plugged the hole. And our result is 431. We are so close, but it's still not right. And honestly, this is the sneakiest mistake of all. Why? Because by telling the formula to just throw out anyone with a blank age, we accidentally tossed out all the women who should have been counted, but just happened to be missing their age in the records. Our logic was too blunt, too aggressive. Okay, deep breath. We've learned from every single one of our mistakes. We now understand the difference between and or. We know that blank cells get treated as 0, and we know we can't just blindly throw data away. With all that knowledge, we are finally ready to build the one formula that gets it right. And here it is, the solution. Take a look at how it's built. The main command is still an OR function, and the first part of that OR is super simple. Is the passenger female? But the second part? The second part is a clever little AND function that's nested inside, and it checks for two things at once. Let's walk through this step by step because it's really smart. First, the formula asks, is this person female? If the answer is yes, great, they get a 1, and the formula stops thinking about them. But if the answer is no, then and only then does it look at the second part, and it asks two things. Okay, for this non-female, is their age less than 10, and is their age cell not blank? See how that works? It perfectly nails our question and avoids all the traps we fell into before. And boom, there it is, 509. That is the correct answer. That number is every single female passenger, whether we know their age or not, plus all the little boys under 10 who had an age listed. It was a journey, but we finally got there. Okay, but let's be honest. That final formula was a monster. It's really hard to read, and it would be so easy to make a typo. So I want to show you a much better, cleaner way to do this. This is what the pros do. It's a technique called helper columns. The idea is, instead of jamming all that logic into one single complicated formula, you break it up into simple little pieces. You make one column that just answers the question, is this person female, with a yes or no, a 1 or a 0. You make another column that answers, is their age less than 10, and maybe a third that answers, is their age blank. Each piece of the puzzle gets its own column, so you can see everything clearly. And the benefits of doing it this way are just huge. First, your work is totally transparent. You can literally see each step of your logic. If something goes wrong, finding the mistake, debugging, is a piece of cake. And maybe most importantly, somebody else can open your file and immediately understand what you were trying to do. It's a simple trick that makes your work so much more professional and reliable. So we started with a simple 2-letter word, OR, and we saw how it led us down this incredibly complex path. The big takeaway here, using this Titanic data, isn't just about getting the formula right. It's about thinking really critically about the questions you're asking. Every single data set, whether it's from 100 years ago or from your work today, has a story locked inside it. The real challenge, the real skill, is making sure you're asking the right questions and building the right logic to actually hear that story.